Hello, hi everyone. This is Bharat Vishwakarma. All of you, welcome to my YouTube channel. Today, our topics is subject is power plant engineering, and ranking topics is Rankine cycle. This is the second part. This is the second part of ranking cycle, my dear. We already have discussed in the first part of ranking cycle basic assumption in a ranking cycle, and basic parameters for the selection of the power plant, and third thing is SSC steam specific steam consumption rate. What is the role of a specific steam consumption rate in a power plant? And next one is Carnot vapor power cycle, and this after that simple Rankine cycles, and the comparison of Rankine cycle and the analysis of the Rankine cycle. We all have done that topics in the last classes, but today our topics is methods of improving the performance of a Rankine cycle. How can we improve the performance? How can you increase the performance? How can you increase the efficiency of the Rankine cycle? There are four methods. They are increasing the boiler pressure. By increasing the pressure of the boiler, we can increase the performance of the Rankine cycle. And the second method is superheating. By superheating the saturation vapor, we increase the performance of Rankine cycle. And third one is reheating. Reheating means heating the streams is a two-stage, okay. And fourth one is a regeneration process. This one is a very important topics for the university exam point of view also, and any competitive exam point of view also is a very important topics, okay. So before starting the today sessions, I want to recall some important points from last class, okay. So which are very important, which are needed to explain these topics. These are SSC, okay. First one is SSC. As you know that SSC means what? Specific steam consumption rate, that is 3600 by W net kilowatt hour. It means what is indicates means it has to determine the size of the power plant, whether the size is small or whether the size of the power plant is bigger, okay na. So specific steam consumption helps to determine the size of the power plant, okay. Second is efficiency. We already know that the efficiency of the Carnot cycle is maximum than efficiency of the simple Rankine cycle. Let you efficiency of Carnot. Efficiency of a Carnot is greater than efficiency of a Rankine cycle, my dear. Now third one is efficiency of Rankine is formula is 1 minus TL by 1 minus TL 1 TL by TM, okay. This TL is lowest temperature and TM is mean temperature. Why you are taking the mean temperature, I already explained about that in the last classes, but thing is that it was in a Nepali, okay. If I get a free times, I will explain that topics last class also in English, okay. So let's start our today's sessions from the increasing the boiler pressure. If we increase the boiler pressure, what are the effects will occur in the Rankine cycle? What is the result we'll get in the Rankine cycle, okay. Remember 1 to 3 points. It will help to determine the effect. It helps to determine the effect in a Rankine cycle, okay. So our topics is increasing the boiler pressure, okay. What will happen if we increase the boiler pressure? So I want to remove all these things, okay. So first topics is our method is increasing the boiler pressure. Okay. So just you observe the diagram. I'm going to draw the TS diagram. You should observe the very carefully the TS diagram. Everything seen on the TS diagram, okay, my dear. This is what? This is temperature, and this x coordinate denote the entropy, okay. This is vapor saturation curve, okay. First we draw the simple Rankine cycle, okay. 1 to 2 process, and this, and 1, this is 1, this is 2, this is 3, this is 4. Yeah, this is, as you know that this is a simple Rankine cycle, okay, as you discussed already in the last classes. But 1 to 2 from turbine indicates the turbine expansion, and 2 to 3 denote the condenser, and the 3 to 4 indicates the pump, and 4 to 1 indicates the boiler. We can supply the heat. Okay, so after increasing the boiler pressure, let's suppose we are increasing the boiler pressure from here to here, okay, 4 to 4 dash, then what will happen? Then this, okay, if we increase the pressure from 4 to 4, what will happen? Let's see. And the cycle became like this. The TS diagram becomes like this, and this will be 1 dash, and this will becomes 2 dash. Okay, now from the TS diagram, observe the diagram, my dear, very carefully. 1, okay, 1 2 3 4 dash indicates 1 2 3 4 dash 1 indicates the simple Rankine cycle. What indicates? Simple Rankine cycle. Okay, now 1 dash, 2 dash, 2 dash, and 3 4 dash, what will indicate? 1 dash, 2 dash, 3 4 dash, comma 4 dash, 1 dash indicates what? New Rankine cycle with increasing the pressure. Okay, after increasing the pressure, the cycle, the TS diagram formation, the cycle formation like this: 1 dash, 1 dash, 2 dash, 3 4 dash, and 1 dash. Okay, this is a new Rankine cycle. Okay, now after that, the pressure at 4 dash, the pressure at 4 dash is greater than 4 dash. Okay, now we are increasing the pressure from 4 point to 4 dash point, and 4 to 4 dash point, we are increasing the pressure of the boiler. Okay, so let's see the effects. What are the effects we are getting after increasing the pressure from the point 4 to 4 dash? Okay, so first and foremost things were observed from the diagram, my dear. Now this is a 1 2 3 4 dash is a 4 is a simple Rankine cycle. After increasing the pressure, the turbine work is increasing. Let's see, this is a from here to here. Okay, now the turbine work is increasing, right, from here to here, which here this is indicates the turbine work. WT is increases. WT, what are the effects? Effects we get, effects are, after increasing the pressure, we get one number, WT increases. How it increases means, first before increasing the pressure, our work done from 1 to 2, but after increasing the pressure from 4 to 4 dash, the turbine work increasing from 1 to 1 dash to 2 dash. So WT is increases. Now coming to the point 2 3, this is a this cycle is this part is the condenser is before increasing the pressure. After increasing the pressure 4 to 4 dash, what will happen? The condenser, the heat rejection part is decreases. The condenser work is reduces from 2 dash to 3 dash. How much it reduces means this part is gone, reduces. Okay, now 2 to 2 dash, this part is what reduces. It means the heat rejection part is Q rejection is reduces. Okay, now it reduces. Heat rejection is reduces. Now coming to the point 3 to 4, what? Before increasing the pressure, 3 to 4, what? 3 to 4 is pump work. Okay, now we compress the liquid from 3 to 4, that means pump work. But 3 to 4, before increasing the pressure, the work done is from 3 to 4. Now after increasing the pressure, what will happen? 3 to 4 days the pump work is increases. It means 3 pump work is pump WP is increases. WP is increases. But as you know that W net is means what? W net means what? WT minus WP. Okay, now in this case both the turbine work and pump work is increases, even though W net is also increase, even though W net also increases. How? I will tell you. It means that with the comparison of a pump work, the turbine work is high. Okay, now with the comparison of pump work, the turbine work is hard. Why? Means as you know that I already explained the last classes. W open cycle, for the open cycle work done is minus VdP. This is this equation from a thermodynamics. This is a minus integration minus VdP. This change in pressure. This is a volume. If you compare the volume, if you compare the volume of a liquid with vapor, the volume of a vapor is a very small. As a result, the work done will be the very small. So WP is a very small with the comparison to the turbine. So that's why the W net also increases. If W net is increases, then what will happen? We already know that SC is what? Specific steam consumption. Specific steam consumption rate is means 3600 by W net, right? W net. So W net is increases. It means that SSC also decreases. SSC also, what happened? SSC also decreases. It indicates what? It indicates means it indicates that the power plant cycle, but the power plant is a very small. What it indicates? The power plants. It indicates the size of the power plant. Okay, so SSC increases means size of the power plant is small. Size of the power plant is small. Okay, my dear. Our next, what will the next effect? And now coming to the efficiency. Okay, now so we can write here SSC specific steam consumption also decreases. Now coming to this, these are the what happens here. This point, what is this? This is a sensible heat. As you know that what is sensible heat, what is the latent heat. I hope all of you know about the sensible and the latent heat. Latent heat means the heat requires to changes the phase. If suppose we are converting from liquid to vapor, means the latent heat is required. Suppose we are converting the same liquid in the same phases, means same phases, means we call it as a sensible heat. Okay, suppose in this case sensible heat, this point, this phase indicates what? Sensible heat phase. Okay, and from here to here indicates what? Latent heat phase. Okay, latent heat. Now we are this almost these two cases are the same. Now coming to the point, this as you know that at the highest pressure from the thermodynamics, at a high pressure, the latent heat is become very low. It means the latent heat is very low in comparison to the lower pressure. So in this case 4 to 1 and 4-to-1 days of the latent heat of the 4 to 1 days, this point has a more latent heat than this case. It means that the supply of the heat, the QS, the supply of Q supply, this point indicates what? 4 to 1 and 4 to 1 days indicates what? It indicates the supply of a heat. It means that after increasing the pressure, what will happen? The QL latent heat decreases. Latent heat, I will write here, latent heat decreases at a high pressure. At a high pressure. Okay, at a high pressure, then what will happen? If the latent heat decreases, means Q supply, and here look at here, the Q supply is also decreases. Q supply also decreases. Okay, now Q supply also decreases. Now decreases, even though all these things, even though all these positive, all these advantages, we are not preferring to this process. Why? What is the reason? Okay, so even though when you increasing the pressure at a maximum level beyond a certain limit, certain value or between certain limit, what happens? This cycle, suppose we are increasing the pressure like this, okay, like this, what will happen? This will happen. It what happens means this liquid plus vapor parts, the liquids will containing more. The liquid means what? Means this part is shifting this side. This what is this part indicates what? Liquid. This part indicates what? Which part is this part indicates the liquid and this part indicates the vapor, right? And now if increasing the pressure maximum beyond a certain limit, beyond a certain criteria, what will happens? There is a liquid plus vapor is formation maximum. It means that as you know that the impact of a liquid, is more than the vapor. Okay, now so there is a chances of creating the corrosion or the erosion take place in the turbine's blade. As a result, there is a damage of the turbine blades take place. There is a chances of damaging the turbine blades. Okay, so that's the reason we are not considering this process at all to increase the performance of the Rankine cycle. So all of you get it. So now second topics. Now I am going to erase it. So second topics is our second method increasing the performance of the Rankine cycle. Second topics is superheating process. Okay, superheating. Okay, superheating. What happens means in this case, in this method, generally we are superheating the saturated vapor at a concentrate level. Okay, so look at observe the diagram. You can easily get that point, easily get the effect to what happens after superheating the saturated vapor. Okay, this is a TS diagram. Look at here, just observe the diagram. It is a very this is a saturation curve line. Now simple Rankine cycle, as you know that this is our simple Rankine cycle. Okay, 1 2 3, this is a 4. Now after increasing the what will the topic is superheating. We are superheating the at a constant pressure. This is at a constant pressure we are hitting the this line indicates the constant pressure. Okay, we are hitting the saturated vapor at a concentrated level. Now what will happen? This is our 1 dash, this is a 2 dash. Before superheating, let's suppose look at here, 1 2 3 4 indicates what? 1 2 3 4 indicates our simple Rankine cycle without superheating. Okay, after superheating, what the superheating cycle indicates? 1 dash, 2 dash, 3 4. Okay, 1 dash, 2 dash, 3 4. Okay, now Rankine cycle after superheating. Okay, now so what happened here means, my dear, at this point at this point, we already discussed about this point. What is there at this point? There is a saturated vapor is there. Saturated vapor is there. When the saturated vapor is entered into the saturation region, superheating region, here the superheater will be there. Okay, now superheater, when the saturated vapor is entering in the superheater, there is a coil is contained in a superheater, and the superheater absorb the heat from the saturation vapor and make it a concentrate stream, make it concentrate stream at this point. Okay, so after that, from that concentrate liquid, that concentrate streams is expanding from 1 to 2 dash in a turbine. Okay, so what will be the effect occurs? Okay, first of all things, without the superheating, the turbine works from 1 to 2. After superheating, the turbine's works will increase from 1 to 2 days. What happens? Here the turbine's works is increases. Now I can erase it. So what are the effects? What are the effects are? Effects are after increasing after superheating. Okay, effects are, okay, first and foremost thing is that the turbine works is increases, WT is increases, my dear. Second thing is that now, without the superheating, the condenser heat rejection is from 2 to 3. Okay, condenser work is from 2 to 3, but now the condenser work is increases from where to where? From here to here. 2 to 2 dash. This is 2 and this is a 2 dash. The condenser work is increases. What will happen? The Q rejection is increases. Now coming to the point, this part is what? This is 3 to 4. 3 to 4 means what? This is the liquid is compressed by the pump. It means WP we kept here. WP is a constant. We are mentioning here, we are considered W pump work is a constant. Now coming to the point, 4 to 1 dash. What will do? In this case, we are supplying the heat. Now, okay, 4 to 1 we are supplying the heat, but now after superheating, what will happen? The heat supply is increases from 4 to 1 dash. It means the mean temperature is increases. We are considering the temperature supply as a mean temperature, considering that taking as a mean temperature supply of heat, and it will increases after superheating from 4 to 1 dash. It means that's 4, right? Now this means our T mean is also increases. T means increases means our efficiency also increases. I will explain you. WT increases, W pump up constant, pump work will be constant. It means that we know that W net equals to WT minus WP. It means it constant, it increases. What will happen? W net what happened? W net increases. W net also increases. W net increases means W net also increases. It means that we know that SSC means what? 3600 by W net. If W net increases, the SSC will be decreases. What indicates SSC? SSC is specific steam consumption, indicates the size of the power plant. It means the size of the power plant is very small. Size of the power plant is very. Power plant also is small. Okay. Oh, it means that 5 point. What will happen? SSC also decreases. Now if the our T mean temperature is increases, it means that, as you know that efficiency we know that efficiency means TL by TM. What is TL? TL indicates the denote as a lowest temperature, as the rejection temperature, lower temperature, and T mean is a mean temperature. Okay, so if our T mean is a maximum, is a high, then our efficiency also become a maximum. It means that the efficiency of the Rankine cycle also increases. Now Now but it has a some problem, both of demerits is this process also, this method also has a some demerits. Okay, so after everything has a every mechanical properties, or any material has their some mechanical limit, also materials limited are there. It means that what we indicate refractoriness is there. Refractoriness means temperature bearing capacity of the materials or any components. Okay, so we cannot increase the superheating temperature beyond the 600 degrees Celsius, my dear. If we increase the if we cannot increasing the superheating temperature beyond the 600 degrees Celsius, if increasing the temperature beyond the 600 degrees Celsius, there is a damage of the, there is a chances of getting the damage of the system, right? So this method also not sufficient, that much sufficient for the increasing the performance of the Rankine cycle. So get it, what are the effects? Again I am going to repeat it. So before, without superheating, the simple Rankine cycle is 1 2 3 and 4. Okay, after superheating, the temperature will increases, right? We are making the saturated vapor to the concentrated steam, concentrated vapor. It means there is a superheater is there. Inside the superheater there is a coils. Okay, now some coils will be there, and that coils absorb the some heat from the saturated vapor and make it helps to make a concentrated stream and concentrated vapor and concentrate, and that concentrated stream is expand from 1 to 2 dash in a turbine. Okay, now as a result, as you compare to this and this, which one is more, which one is bigger? This one is bigger. Then turbine is work increases, Q rejection is increases. Before without superheating, the rejection is a 2 point, right? Now after superheating, what will happen? The temperature rejection, the Q rejection will be increases by from 2 to 2 dash is increasing. This is increasing part. And third one is 3 to 4. We are considering this part as a pump work done, and here the pump work done is a constant, right? So after WT, as you know that WNet means WT minus WP. WP is a constant, right? So WNet is increases. As you know that specific steam consumption means 3600 by WNet. If the WNet increases, specific steam consumption also become a small. As SSC become small, means the size of the power plant is a very small. Now Tmin, we are adding the temp to what indicates the Tmin means the temperature. It indicates the mean temperature value. Before the superheating, the temperature indicates from here to here. Now 4 to 1. After superheating, the mean temperature from 4 to 1 dash. This part is going to increases, right? So Tmin is increases. As a Tmin increases, the efficiency also increases. Why? Okay, so the efficiency also increases. Now third topics, our today last topics method is I'm going to explain, that is a reheating process. Okay, a reheating process. Reheating process, it itself has a meaning, my dear. Reheating, heating the steam in a two cases, heating the steam in a two part. Okay, now so first we are heating the steam, we are expand that steam in a partially expansion take place in a lower press turbine, and then remaining, and again we are going again that steams we are transfer to the boiler, and that steams again transfer to the high pressure turbines, and we are going again that expansion take place there. So I am going to explain these topics also. There is a block diagram also is there. So I am explaining about this diagram in a TS diagram. Okay, just observe it. This is our vapor saturation curve. Now first thing is that the steam is expand. Okay, the steam is partially expand from 1 to 2. Okay, partially expand 1 to 2. Again after that we are going to heat it again this. Okay, 2 to 3 we are going to heat it. Then the steam is expanded 3 to 4. Now okay, now 1 to 2 the steam is partially expand take places, and we are heating that steams to the, again we are sending this steam to the boiler and heated from 2 to 3, and 3 to 4 the steam is again expanded in a turbine. Now this part is, what is this part? This phase is our this is our condenser, this 2 3 4 and this is 5, and this is I am doing, and this, okay, this is 4 5, this is a 6, and this is our this is, okay, 1 2 3 4 5 6. Okay, this is our super reheating process. Without heating, okay, now without reheating, what we get? We get this is this is 2 point, okay, now 2 dash without heating, right. So I'm comparing the simple Rankine cycle with a reheating Rankine cycle. Okay, so without heating we get this. What are the effects? What are the basic effects in this cycle? Let's observe. Simple, my dear. What will happen? Right? Before, without heating, with a superheating, without reheating, what will you get? The first and foremost thing is that turbine works increases. The second thing is that the Q rejection also increases. Now this 5 to 6 indicates what? Means 5 to 6 indicates the pump port, but here we consider the pump port WP as a constant. Okay, now constant. And the 6 to 5, look at here, without a reheating, our we are supplying the heat from 6 to 1, okay, 6 to 1, but in a reheating process we are supplying the heat from 6 to 3 dash 6 to 3. It means that our 3 4 our supply of heat also increases. The supply of Q also increases. The main reasons of doing the superheating means increasing the dryness fraction, increasing the dryness fraction of the steam. Dryness fraction we consider as a X. Generally dryness fraction increases. Dryness fraction increases. If we come to the point of efficiency, okay, now efficiency is depending upon the, I already explained in the last classes. Efficiency means the function of a mean temperature. Okay, so if we add the temperature, so mean temperature, okay, I will explain by some diagram. You got it, the point, right? You got the effect. Now coming this point, we are adding the temperature. We are supplying the heat at a high temperature point. Okay, we are supplying the heat at a high temperature point. I will draw the next. As you know that efficiency is a 1 minus TL by Tm, right? So I am draw the next one diagram, so you easily understand that point. Easily understand the efficiency, how the efficiency depend upon that mean temperature. This is a one diagram. Okay, so this is a T, this is a S, this is S. Now this is a curve, right? So suppose we are adding this is expansion take places. We are adding the temperature eta 1 2, okay, 2, this is 3. We are in this case, okay, look at here, this is 1 2 3 4 5, this is a 6. Okay, now so in this case, just look at this two diagram. You will easily understand the concept of efficiency, how the efficiency increases. Okay, so in this diagram we are supplying the heat at a highest temperature. Okay, now we are supplying the heat at a highest temperature. Look at here, we are supplying the heat at high temperature, but in this case we are supplying the heat at a lowest temperature. It means that the Tm is a here is a high. Okay, in this case the mean temperature value is high in this, but in this case the mean temperature value is low. Why? Means we are supplying the temperature at a lowest point. Okay, from here to 1 to 2 expansion take places. When we heat it from 2 to 3 region, we are supplying the heat from lower point to the higher point. So so the mean temperature becomes the very low. As a result, as we know that efficiency means what? 1 minus TL by Tm. If this is a low, the value will become the less. Now in this case, when the temperature is added at a highest point and the Tm becomes the becomes the maximum, if Tm temperature becomes the maximum, then the efficiency of the efficiency also maximum. Okay, these are the basic condition. So in this case we are increasing the efficiency of the performance of a Rankine cycle by 4 to 6%. The main motto of this cycle is to increase the dryness fraction. It means removing the liquid. Okay, so this much for this session, this much for today's session. If you have any doubt, if you have any questions regarding these topics, you can comment. Okay, so I can rectify that. So if you have other things, our regeneration is remaining there. Next topics our regeneration, right? Regeneration topics is a very important. Regeneration process is a very important for the university exam point of view also, and for any competitive exam point of view also. I will give the very conceptual clarity of about these topics. Okay, now I will explain in the next topics, next classes, next session. Okay, so okay, all of you, bye bye, take care, stay safe.